let's get started again. We have 2 more talks before our poster session. The first one is going to be given by Matt because, again, Michelle will be here tomorrow, but apologizes that she can't be here today. This is the Geomatrix Revealed, Knowns and Unknowns about Alaska Volcanoes. And after this, we'll then hear from John Howard. All right, so Matt, thank you so much.
Thank you. So yeah, this is Michelle's talk. I'm gonna do my best to give it. I've deleted a few things that I didn't know quite what she was trying to say, and still probably a few more in there that I'm not quite sure about. And this is something that any of the other AVO geologists are welcome to chime in on. So the Geomatrix, what are we talking about? So the AVO geology group, you might see where we've gone and done field work and been like, why did they go there? Why did they do that? Well, there's kind of 2 routes. One, opportunistic, a volcano erupts. We obviously try to study that if we can. Geophysics goes and installs a new network somewhere. There's an opportunity to tag along for the ride. We take advantage of opportunities where we can get them. But then sometimes there's a windfall of money, and we actually have targeted funds to do geology work. And then also sometimes, like kind of the current climate, there's ever diminishing funds, and we're trying to prioritize where we do that remaining work. And the Geomatrix is the guidelines that we use internally, loosely, they're not rules, they're guidelines, to try to prioritize where we're doing our geologic work, which then affects what is available in our archives for you all to work on. So as has been brought up, there's a lot of volcanoes in Alaska. If you've ever, the state publishes the 54 historically active volcanoes. Those are not erupted volcanoes. I like the statistics. There's about a little more than 30 volcanoes that have had documented eruptions in the last 300 years. Those are in red. And then there's a little over 80 volcanoes that we're fairly certain have Holocene eruptive activity. So 80 volcanoes that we would as geologists consider active. That's a lot of volcanoes. Some of them, most of them are extremely remote. How do we prioritize where we do that work? As a starting point, we have been using the threat levels. So this is from these are from the 2018, the most recent edition of John Uritz's volcano threat ranking for the country. So it breaks down volcanoes into very high in red, high in orange, moderate in yellow, low in green, and then very low in blue. So this is kind of a semi-quantitative attempt to qualify how threatening is a volcano. And that's a combination of both what is the risk, exposure to communities, exposure to airline routes, and what is the likelihood and hazard of the eruption. If it just makes a bunch of low lava flows, probably not very hazardous. If it has really big eruptions, it's more hazardous. If it erupts frequently, it's more hazardous. And this is, yeah, just a best effort attempt at this. You're probably familiar with this publication. And we're not immune from kind of more the NSF style priorities, like what are the raw science priorities? We're trying to learn to understand volcano science. And this is just a smorgasbord of different things that have been out there. One of them highlights Augustine there in the far left, and trying to also focus our studies on better understanding the science. So what are the elements of this? This is the elements of the hazard assessment. I'm not quite sure that's the right title, but it's really the elements of this geomatrix. So you can nitpick whether these are the right choices, but these are the choices we've been working with. Geologic map and eruptive history studies. Publications on the actual Holocene eruptive history, this kind of recent active eruption history, publications on the magmatic systems, publications interpreting the unrest that we've seen at the volcanic center, and then a hazard assessment, and then this last point, which we're not going to really talk about, which is this database of information, which you'll see tomorrow is something that we're actually check off fairly well across the board here in Alaska. And then that's not to say that, especially for a hazard assessment, that's kind of the data in. There's still the work to do to get that information out, working with interagency partners, reviewing the research, the instrumentation, working with the geophysics and the field engineering teams, and communicating this stuff out, not just in the scientific publications, but actually with the community members and stakeholders who are affected by the eruptions. So this first factor, geologic studies of the eruptive history, the kind of the classic bread and butter of this is the good old-fashioned geologic map. there's not a lot of geologic maps on Alaska volcanoes, and the ones that are out there are of really a wide variety of detail. And these are not ever going to be like cascade geologic maps where you can walk every contact potentially, because the work is typically supported by brief week or 2-week helicopter campaigns where you've got weather that you're contending with and bears, and you're really doing spot checks of the geology that you are interpreting from probably digital elevation models or satellite images. And this has guided a lot of the fundamental studies, and here's an example of some of those recent publications, like the Kuguyak map. Sometimes the maps are a little more just schematic figures in the paper. They're not necessary, and that does kind of, it counts for something, even if it's not a formal geologic map. And then you go to all the way to the Okmok geologic map, which endured multiple eruption cycles as it came out and kept changing as the landscape changed. Holocene deposits and stratigraphy. This is looking at that kind of the recent eruptive history. I think Holocene, a lot of that in Alaska is because we don't have much of an eruptive history prior to the Holocene, because glaciation swiped away anything that was loose off the surface. So we really focus on that Holocene history. It has the advantage that as geologists, we know if something happened 10,000 years ago, it almost certainly could happen again. You know, where we get into dormancy is when we're talking tens of thousands to hundreds of thousands of years ago, and that's not something we have to worry about from a explosive history. Magmatic system studies. The examples shown here are all kind of your classic cross sections of magma chambers and things, but I think that this more honestly incorporates all the modern petrologic techniques we throw at systems: melt inclusion studies, diffusion studies, really trying to understand the petrology and how that builds on the plumbing and magma supply of a volcanic system, and how we can then interpret unrest there. And this is a lot of what I think as a community we're focused on these days, are these types of studies. Then interpreting unrest, this is where geophysics comes in and gets into the geomatrix, obviously, but also the geologic interpretation of eruption samples. This, of course, only really happens when we have unrest, but there's many examples of volcanoes where we have geologic unrest, and I don't think anyone's written a paper on it. So let's say there are plenty of opportunities for work even on that. And then the hazard assessments. These are examples of old generation hazard assessments, a lot of lines showing, you know, lahars going down valleys in Alaska. Almost certainly there's no one in those valleys, a couple exceptions. There's a lot of thinking in the USGS about next generation hazard assessments. I'm still not entirely sure what that means. I think everyone's still trying to figure that out. Sounds good. But it's important. It's thinking a lot, actually, to be more serious, it's thinking more about like what are products that the stakeholders need, like what does the community need, what do people need to see from a hazard assessment. So this is an ongoing, really it's the ultimate goal of a lot of this stuff, is to support hazard assessments. So what is our rating scheme? So I mentioned, if you have a volcano that has not had any historical unrest, kind of unfair to rate it down for not having any publications on the interpretation of that unrest. So there's some exceptions to this. Same with Holocene eruptive history. Some volcanoes don't have a Holocene eruptive history. But really, we've got all these different categories, and we're trying to say, how well do we know information in these categories? And I'm not going to be able to show you the details of that, but there's a poster up where you can actually see what those different rating scales mean. Like, what's a level 1 geologic map versus the gold standard level 3 geologic map? And we try to do that for each of these different categories. And then we try to figure out what our desired knowledge is. And this is kind of the fuzzy thing, but the idea is we want to know more about the very high threat volcanoes than we want to know about the low threat volcanoes. But we want to know something about all the volcanoes. And the important lesson on this is that sometimes that low threat volcano, when you study it, becomes higher threat. So especially here where we have some volcanoes that we've never sampled. No one has actually been, no geologist has been on the island. So that's an important implication. So how much do we want to know about the volcanoes? How much have we published it? And then what is the knowledge gap? And that factor there is what then tries to drive us towards investing resources when we're not otherwise just following opportunistic chances. So the idea is that, you know, we're trying to scale our desired knowledge with the threat level. And this is similar to what I think the monitoring approach is, and which is also say the monitoring system also sometimes throws instruments on a lower threat volcano because they can, because it's nearby and it's logistically feasible, versus something that's higher threat, but just not able to get to it and keep the network alive. So I mentioned this rating scheme, a lot of words. We've got on the factors up and down and a 0 to 3 score. So 3 is we know a lot, 0 is we know nothing. You can look at this in the posted presentations, or I think we can find a way to share this. I mentioned 2 of these categories, Holocene eruptions and unrest. Obviously, if not, that could be not applicable. So an example, this is readout. It's a very high threat volcano. So we've just said we'd like to have 90% knowledge of this volcano. It's just a number. What is the published level of knowledge? So it's 73%. And if you look at this, if you read these whole categories, there's a hazard assessment, but it's not the latest generation hazard assessment. So it's a 2. There's a lot of studies from the 2009 eruption on the interpreting the unrest. So it gets full marks on that. It gets full marks on petrologic studies. It's got kind of not quite there on Holocene stuff. And there's the map is old and needs to be refreshed. Now, there's a flaw in this, which is it would say we don't need to do any more petrologic studies on readout. And there's someone in this room who's doing melt inclusions on readout. There's no volatile states. There's obviously holes in this where there's still more knowledge that is needed in these categories. So it's not to say that there's not work that needs to be done or that we wouldn't necessarily invest our resources too in doing that work. But if you wonder why we're not doing that, it might be because we're seeing that there's a bigger hole in the geologic mapping, and that's maybe more where we're worried about focusing resources. Yeah.
I'm like being unconventional, asking a question.
Yeah.
If one of these, for instance, has a 1, in a different category, is it more likely that you would get funding based on which category it is that might have a 1 versus the 3? Like, is geologic mapping, is that something you can actually argue we need to put a lot of money into this? Or is it a lot easier to say we need to put an instrument or like get some petrology on this? From a funding perspective.
We're not really getting like earmark. We're more, I guess the way this ties into funding, and some Chrissy might actually be able to speak more to this, but this is like a metrics that we can report up the food chain of what have we accomplished? Are we moving towards a goal? And then that can be used to say like how much money you get allocated. It's like, oh, you're not, they want to see progress. So I guess a consequence of this would be as we go up the USGS food chain, completing a melt inclusion study at readout isn't going to get us any kudos. And that's a consequence of this framework. It's not perfect. Now, the positive to it is a framework and it is trying to be more strategic as opposed to just saying, I'm interested in this volcano, I want to go there. Well, why? What's the whole knowledge gap in this? And, you know, I think there's room for evolution of this and thinking more about what are the different categories. Yeah. And of course, petrology, which a lot of us are, is like only one component of the geology of a system, which also has a bias that I have at least. And we're doing that. So category ratings, the threat rankings, those are subjective. And they're also we've got these categories that are broken down, but actually it's a continuous scale that the report follows. So something might be just below very high threat, but it's high threat. Does that really mean that the knowledge level drops in a big jump? Not necessarily. The threat rankings are not static. We learn more about volcanoes and they become higher threat. Or, you know, sometimes islands used to have a village and the village is gone and they're not as high threat anymore. We have not probably caught all of the literature that's been published on these. So we're probably, you know, not actually as up to date as we could be. And this is used again for internal planning. This is not necessarily our funding proposal. This is more every year when the geologists of ABO get together and try to figure out what we're going to do with the resources we have. How should we direct that in a strategic way? But it does help us identify gaps and opportunities. But again, not definitive. We don't have, it's a guideline, not a rule. So there it all is. Enjoy. I'm done talking. This is actually printed out in the hall. Tomorrow, Michelle will be here. Talk to her about it. But this is the whole thing. So red up there at the top, that's our very high threat volcanoes. Orange is our high threat volcanoes. Yellow is our moderate threat. Green and blue are our low threat volcanoes. These are going to change. They're going to change in a couple of years when Tim gets the next version of this out, because we've learned about the volcanoes and some volcanoes are going up and some are going down. As an example, the high threat volcanoes, this is Redoubt, Spur, Akutan, Makushan, Augustine. We actually do have pretty good studies on them. By this, we probably shouldn't be putting a ton of resources into them. And you'll see we don't tend to do big geologic field campaigns on our very high threat volcanoes anymore. And that's because we have done a lot of work on them. But that's not to say, and we have a lot of eruptions, like they're high threat because they've had a lot of eruptions, which leads to us having done those studies. But it's not to say that there's not more work that's desired, especially you look at a place like Spur, which we've been getting excited about. There hasn't really been a lot of work done on the geology since the 90s. We've learned a lot about volcanoes since then. So a lot of room for improvement and a lot of opportunities because the work has been done for the community to come in and do the work. And of course, I think from like an NSF perspective, you can sell, I'm working on a very high threat volcano. That sounds better, but maybe, and then we just want to, sorry, I forgot about this part. We've also tried to start doing a better job of recognizing the unpublished work that we've done. This is the in progress work, and this is on the poster. And, you know, the geologic map for readout and Spur has been going on for over a decade, I think. But, you know, these are long-term projects that take a long time to finish, and then people get distracted by new eruptions. And we kind of want to try to acknowledge, like, maybe we're not doing more field work at readout to the geologic map because it's done. What we really need is the office time to finish that project and to try to share that more with the community. But then, you know, when you look at the high threat volcanoes, you can see what we know is a little less. Of course, our desired level of knowledge goes down. There's places like Okmok and Katmai that are really exceptionally well studied. And that there were long-term research projects there, but there's a lot of future opportunities in this group. So I think one thing to sell to like a funding agency is that just because it's not very high threat doesn't mean that it doesn't have knowledge gaps. Maybe the knowledge gaps are a little lower down, and that's where the community should also look to, not just focus on the big flashiest players. And again, just a kind of a snapshot of some of the work that's going on these. We're doing a lot of work on these volcanoes too. And then you get to the moderate threat volcanoes, and this is where we kind of just drop off with some like crazy exceptions. Like you find Boguslav, and it's like, wow, we know a ton about Boguslav. Well, it erupted, and we did a ton of work on it. So that's kind of where you get these like exceptions to the trend. And then some of these, like Edgecombe is a good example that was moderate threat that's going to probably move up to high threat because it started having unrest historically. So kind of a new interest in doing things. Another example is the Dagdak. It was previously thought that all the eruptive activity on Adak Island was from Moffat in the Holocene. Turns out it's from its little sibling up to the northeast at Agdak. So they're basically going to do a little switcheroo in their threat ranking. But that's why we do geologic studies, even on these moderate threat volcanoes. And you can see we're doing a lot less work on these. That also means potentially there's a lot less available samples to work on these as well. And then, of course, the low and very low threat volcanoes. There's not a lot set here. Another good example, though, would be Davidoff Island. It's low threat. Nobody had ever been on the island, as far as we can tell. There's like I think there was a skiff to the shore thing that happened after World War II. But we got out there during an opportunistic work and were able to document like very large rhyolitic pumice falls all over the island. So it's a pretty significant volcano. We still don't know how old the eruption was. So not to ignore the low threat volcanoes because we need to know something about them. So that just brings us to the opportunities to say that, you know, there's a lot of room to do more in-depth studies of individual eruption deposits. You know, we've maybe worked a lot. A great example of people in this room have worked a lot. We've had a lot of studies that AVO has done on the 2006 Augustine eruption. Very little has been done on individual eruptions from its Holocene history. That's something that Sloan, during her master's degree, did a lot of work on. And it's a really great example where we're probably not going to get beyond that quick survey of the eruptive histories through the Holocene from our perspective, checking off that box number 2. There's a lot to be learned by diving into any one of those eruptions, which often might be more exciting than the historical eruptions, might be much bigger eruptions that happened mere hundreds of years ago, but we've barely studied them. We have a lot of petrologic studies on volcanoes that have these really good, adequate, like well-sampled systems. I added this part, which is to say, I think the big opportunity is all the cutting edge techniques, melt inclusions, diffusion studies, isotope work. This is stuff that we almost never have time or resources to dedicate to. This is the hot stuff to study in petrology and get grant funding for. And that's the opportunities here for a lot of these studies. And Michelle had topical projects, things like edifice stability, and then of course along our studies, things like that. That's what Michelle had. Ask her questions. I can try to answer questions, but I'd ask other people to help me.
Good question. So for the knowledge gap metric that you use, do we only count publications?
It does. So what I think we're trying to do is better for our internal planning, well, specifically field planning, start recognizing the difference between what is our published knowledge gap and what is our knowledge gap. Because if our published knowledge gap is different than our knowledge gap, it's a sign that we need to crack the whip and get our publications out. And if our knowledge gap and published knowledge gap are lacking, that's a sign we should throw field resources at that area.
Yeah, I kind of have a suggestion
Yeah.
on that. Like, when you mentioned Davidoff, I think 2 or 3 years ago, where the annual summary talked about the seismicity there, when you had a swarm at Davidoff.
Yep.
So maybe having like a column where, these are the years of annual reports where it's mentioned, which might not necessarily involve with the manuscript, could be useful.
I think that ties in a bit to the threat ranking, right? Because if like Davidoff will go up in threat ranking partly because it has had unrest. Although the caveat to that is that unrest category was that unrest caused by something magmatic. And for a place like Davidoff, I don't know that we actually know what the seismic swarm was. If it was like, I don't think that's consensus on the geophysics end, which is to say there's room, John's talk is next on this, but there's room for similar discussion in the geophysics world of knowledge gaps. So, yeah. Anyone? Yeah.
Can I make a comment?
Yeah.
So Diana and I put together a proposal. I mean, God knows if this is ever gonna go anywhere anymore. But we did, with your help and a bunch of other people, make a different matrix. It was for all the eruptions that have happened in the instrumental time in the past 20 years. And it's more granular. It does have melt inclusion studies and detailed geodesy and is there tougher lava? So maybe it's something we could share, because in a way it's really like, how well has each eruption been studied? And maybe that's something else that people be interested in.
Yeah. And I should acknowledge, so this was Michelle's talk. I know Michelle and Tom Sisson are actually working on trying to write a paper about this. I would like to kind of share this more broadly and get it out what this is. Yeah, ask Michelle about that.